So once again friends, we are here to revise the methods of solving differential equations. In the first lecture, we discussed several types of solutions of differential equation like variable separable method, then homogeneous form of differential equation, linear differential equation, Bernoulli's differential equation, and exact differential equations m dx plus n dy is equal to 0, where curly m by curly y is equal to curly n by curly x. Then we discussed differential equations which are not exact but contain the terms like x dy minus y dx or x dy plus y dx. Now we come on to some general case. There are 5 rules, as I told earlier, to find the integrating factor for non-exact differential equations of special kind. So first, if your differential equation m dx plus n dy is equal to 0 is not exact, but m and n are homogeneous and they contain all the terms of same degree in x and y. In such a situation, the integrating factor will be 1 upon mx plus ny, providing mx plus ny is not equal to 0, because if it is 0, then 1 upon 0 is weak. We cannot have anything from this then. So as I told you earlier that for every method we will have some illustration, one example. So here I am taking one example of a homogeneous differential equation where all the terms of m and n are having same degree. So let us have an equation: x square y minus 2xy square dx plus minus x cube minus 3x square y dy is equal to 0. Look at this equation. There are 2 terms in m, 2 terms in n. Here m is x square y minus 2xy square, and your n is minus x cube minus 3x square y. This term is having degree 3. 2 from here, 1 from here, so total degree is 3. Here again 1 plus 2, the degree is 3. It is clearly 3, and once again here 2 plus 1, the degree is 3. That means all the terms in m and n are of the same degree 3. That means this is homogeneous differential equation of the type m dx plus n dy is equal to 0, which is not exact. So what will be the integrating factor? Integrating factor in this case will be 1 upon mx plus ny. That means 1 upon, this is mx, here it is your m, multiply it by x. What you will get? You will get here x cube y minus, here you will get 2x square y square plus ny. N is negative of this, and when multiplied by y and adding to this, you will get minus x cube y plus 3x square y square. The term x cube y is cancelled out. This is 3x square y square minus 2x square y square. So 1 upon x square y square is the integrating factor. This is just the integrating factor, not the solution. What we have to do now, we will multiply the given differential equation by this integrating factor. So multiplying by 1 upon x square y square, this differential equation we will multiply by 1 upon x square y square. What we will get? Look at the calculation. When multiply into this first bracket, we will get x square y divided by x square y square, that means 1 upon y, minus 2xy square divided by this is 2 upon x dx. Similarly, in the second bracket, x cube divided by x square y square is x over y square, and minus 3x square y divided by x square y square is 3 divided by y dy is equal to 0. Now we have to collect the terms from here. One thing is clear, that 2 upon x dx we can integrate directly, 3 upon y dy we can integrate directly. The problem will be for the first term and the third term. Collect these two terms in one bracket, you will get 1 upon y dx minus x upon y square dy, and the rest of the terms are minus 2 upon x dx, and this is minus multiplied by minus is plus, 3 upon y dy is equal to 0. Look this bracket carefully, this is nothing but d upon x upon y. Actually, d of x upon y means d of x into 1 upon y. So here we will get derivative of x and d of 1 upon y. 1 upon y d of x. 1 upon y d of x plus x, and d of 1 upon y is minus 1 upon y square dy. So d of x upon y is this bracket minus 2 upon x dx plus 3 upon y dy is equal to 0. Now the process of integration is very easy. Integrating both sides, the first term integral will become x upon y, obviously, minus this is 2 times log of x plus this is 3 times log of y is the constant of integration, which is the required solution of this homogeneous differential equation, where each term of m and n are of same degree 3. Now we will move on to the second method. In the second method, the differential equation m dx plus n dy is equal to 0. This equation m dx plus n dy is equal to 0. This equation is of the form y into some function of xy dx plus x into some function of xy dy is equal to 0. What it means? Actually here m is a function such that if you take y common from this, then everywhere in the rest of the function you will find the term xy together. Similarly, in n, if you take x common, then everywhere in the remaining portion in n you will get the term xy together. In such a case, the integrating factor will be 1 upon mx minus ny, provided mx minus ny is not equal to 0, because of the same reason, if it is 0, 1 upon 0 is meaningless. So we will have to discuss one case also, one illustration of this type. So I am taking a question now. Let this question be y 1 minus xy dx plus x 1 plus xy dy is equal to 0. Look into the m and n. in M, y, this y is away outside from the bracket, and in the rest of M, xy is as a single term. Similarly, in N, x is common, and in the bracket you are having xy together. There is no single x, there is no single y, there is no term of the type x square y or xy square or x cube y or x cube y square, etc. So this equation is in this form. Since this equation is in this form, as we discussed, the integrating factor will be 1 upon mx minus ny. What it will be now? Let us calculate mx. This is your y, 1 minus xy, this is your m. And now multiply by x, you will get xy here. And now open the bracket, you will get xy minus x square y square. And minus ny. This is your n. X, 1 plus xy. When you will multiply by y, you will get here xy. And opening the bracket, and keep in mind this sign minus outside, what you will get? You will get minus xy minus x square y square. This xy term is cancelled out, and here integrating factor is minus 1 upon 2x square y square. This is just the calculation of integrating factor. Still, we are to solve the differential equation to find its solution. Now, IF is with us, that is minus 1 upon 2x square y square. What we are to do now, we are to multiply this equation throughout by minus 1 upon 2x square y square. That means the integrating factor. You will have outside minus 1 upon 2x square y, 1 minus xy dx, and here you will get minus 1 upon 2xy square, 1 plus xy dy is equal to 0. Multiply the bracket inside, multiplying inside the second term, because it is minus also here, the second term will become positive. You will get 1 upon 2x minus 1 upon 2x square y dx, and here you will get minus, multiplying inside, you will get 1 upon 2xy square plus 1 upon 2y dy is equal to 0. Actually, the main role of this integrating factor is to make the differential equation exact. We have multiplied the given differential equation with integrating factor, so there is no need to check whether this equation is now exact or not. It is exact. And your new m is this. Your new m, including this minus sign, is this. So you have equation again, m dx plus n dy is equal to 0, but now this equation is exact. And once the equation is exact, we know that the solution of this such differential equation is integral of m dx, treating y as a constant, plus terms of n not containing x, and then dy is equal to the constant of integration. So what the solution will be here? It is integral of m dx. This is your m, 1 upon 2x minus 1 upon 2x square y dx, treating y as a constant, plus integral terms of n not containing x. Here we are having two terms in n. This term contains x. This is the only term which does not contain x. So keeping in minus sign in mind, the only term will be minus 1 upon 2y dy is constant. And now the integration is very simple. 1 upon 2x means 1 upon 2 log of x, and minus 1 upon 2x square y. When you integrate, you will get plus 1 upon 2xy minus 1 upon 2 log of y is constant, which is the final solution of this differential equation. This is the second type when the equation is not exact and we have to find the integrating factor. Now we discuss the third case. The third case is if a differential equation which is not exact of the type m dx plus n dy is equal to 0. We will check if curly m by curly y minus curly n by curly x divided by n is a function of x only containing no y. If such a case is there, integrating factor will become e raised to the power integral of this fx dx. So let us discuss a case once again. So let us have a differential equation, but keep it in mind that integrating factor in such a case will be e raised to the power integral of this quantity, that is fx dx. So we will have one equation, one differential equation of this type. So let it be x square plus y square plus 2x dx plus 2y dy is equal to 0. Look into this equation. What is your m? Your m is this and your n is 2y. What will be curly m by curly y? That means partial derivative of m with respect to y. It will be 0. Derivative of this term will be 2y and it is again 0. On the other side, curly n by curly x. So n is 2y. When you differentiate it partially with respect to x, the derivative will become 0. What is curly m by curly y minus curly n by curly x divided by n? This is 2y, this is 0, and your n is 2y, so it is 1. This is a constant, and any constant can be treated as a function of x, can be treated as a function of y, can be treated as a function of z, can be treated as a function of t, and so on. So I can take this one as a function of x. Since it contains no y, the integrating factor in this case will be e raised to the power integral of fx dx, that means 1 dx, so it will become e raised to the power x. This is the integrating factor. After finding the integrating factor, our next job is to multiply the given equation with integrating factor. So multiplying this equation with e raised to the power x, what we are going to get? The equation will take the form x square e power x plus y square e raised to the power x plus 2x e raised to the power x dx plus 2y e raised to the power x dy is equal to 0. Since we have multiplied the differential equation with its required integrating factor, the equation is now exact. And once the equation is exact, the solution we know is integral of m dx. This is your m, x square e power x plus y square e power x plus 2x e raised to the power x dx, treating y as a constant, plus integral of terms of n not containing x. There is only one term and that contains x, so there is no term not containing x. Dy is equal to constant. So this we need not to eliminate, this is already a constant which will be amalgamated with this constant. And for this integral, the first integral x square dx, x square e raised to the power x, we can solve it by parts. The third one is again by parts. The second one, y square is taken outside and integral of e power x is e power x. So I think it is easy to solve for you, is equal to a constant will be the final solution. Now we move on to the next method. In the next method, where the first three methods are failed, we will check if curly n by curly x minus curly m by curly y divided by m now is a function of y only. Earlier it was a function of x only, now it is a function of y only. In such a case, integrating factor will be e raised to the power this function dy. So I am not taking any example for this particular case because it is very much similar, almost 99% similar to that of the previous method when we were treating with curly m by curly y minus curly n by curly x divided by n was a function of x only. Now curly n by curly x minus curly m by curly y divided by m is a function of y only. So integrating factor will be obtained, and after multiplying by integrating factor the equation will become exact, and the solution will be integral of m dx treating y as a constant plus terms of n not containing x dy is the constant of integration will be the solution. So we move on to the final method of these 5 rules. This is if your equation m dx plus n dy is equal to 0 is of the type x raised to the power a, y raised to the power b, my dx plus nx dy plus x raised to the power p, y raised to the power q, m dash y dx plus n dash x dy is equal to 0. If your equation is of this type, then what to do? The integrating factor will be x raised to the power h, y raised to the power k, where h and k will be obtained using two relations. The relations are a plus h plus 1 over m is equal to b plus k plus 1 over n, and p plus h plus 1 over m dash is equal to q plus k plus 1 over n dash. What we will obtain from these two? We will obtain two linear equations of x and y. Two linear equations in h and k. Solving those two, we will get the values of h and k. Substituting the values of h and k over here, we will get the integrating factor, and after multiplying by integrating factor, the equation will become exact. Now, one problem is how to identify such a differential equation. Such a differential equation can be easily identified that one of the two terms in dx, m will have two terms, n will have two terms, one of the terms in m and one of the terms in n will have same degree. The other two terms will also have the same degree. Maybe two terms, one in m and one in m, are of degree 4, and maybe the second term in m and second term in n may be of degree 2. So collecting these terms, the equation will take this form and we can solve by this method. So once again, I consider an equation. So write down 2x square y square plus y dx plus x cube y minus 3x dy is equal to 0. Look into this equation. Now, in this equation, what is the degree of this term? Is 4. What is the degree of this term? Is 4. That means degree of one term in M matches with the degree of one term in N. And the degree of second term in M matches with the degree of second term in N. Collecting these terms, if I collect these two terms in one bracket and these two terms in other bracket, what I will obtain? From these two, x square and y will be common. X square, y will be common. Here you will get 2y and dx. Here you will get plus x square, y is common, so you will get x and dy plus in the other bracket you will get y dx. There is nothing outside, it is y dx, and the other term is minus 3x dy is equal to 0. So this equation is now in this form. You can write here outside x raised to the power 0, y raised to the power 0. Comparing these two now, look at these two. What is your a? Your a is 2. Your b is 1. Your m is 2. Your n is 1. Your p is 0. Your q is again 0. Your m dash is 1. And n dash is minus 3. Now we were having two relations, a plus h plus 1 over m is equal to b plus k plus 1 over n, and p plus h plus 1 over m dash is equal to q plus k plus 1 over n dash. Substituting the values of a, b, m, n, p, q, m dash and n dash in these relations will take the form. Here a is 2, 2 plus 1 is 3, so it is h plus 3 over m, m is 2 is equal to k. B plus 1, b is 1, so 1 plus 1 is 2 over n, here n is 1, and h, p is 0, so 0 plus 1 is 1 over m dash, so m dash is 1 is equal to k plus q plus 1, q is 0, so 0 plus 1 is 1 over n dash is minus 3. Now cross multiply and simplify, this equation will become h minus 2k minus 1 is equal to 0. This equation will take this form, and the second relation will be minus 3h here minus k and minus 4 is equal to 0. So multiplying by minus sign both sides, it will become 3h plus k plus 4 is equal to 0. So this is the other relation. Now what we have to do? We have to solve these two equations. If you multiply this equation by 3 and subtract this equation from this, 3h will be cancelled out. You will get k plus 6k, that means 7k, 4 plus 3, that means plus 7 is equal to 0, giving k is equal to minus 1. And substituting the value of k is equal to minus 1 in either of these two equations. So suppose you put it here, this will become 3h plus 3 is equal to 0, means h is also equal to minus 1. Your k is minus 1, your h is minus 1. So what will be the integrating factor? Integrating factor will be x power h, y power k, that means x power minus 1, y power minus 1, or you can say 1 upon xy. This is your integrating factor. But yet now the equation, the differential equation is not solved. We are only able to obtain the integrating factor. Now what we have to do? We have to multiply the given differential equation with this integrating factor. So multiplying this differential equation with integrating factor 1 upon xy, let us see what the form this equation is going to take. When you multiply 1 upon xy in the first bracket, you will get 2xy plus 1 upon x dx, plus multiplying the second bracket, you will get x square minus 3 upon y dy is equal to 0. Since we have multiplied the given differential equation with integrating factor, no need to check whether it is exact or not, it will be exact. And since the equation is now exact, the solution will be integral of m dx, treating y as a constant, plus terms of n not containing x dy is equal to the constant of integration. So what we are going to obtain, m dx, your m is now 2xy plus 1 upon x dx, treating y as a constant, plus integral of terms of n not containing x. This term contains x. This is the only term which does not contain x. So you will get here minus 3 upon y dy is equal to the constant of integration. That means the solution is, now you have to integrate with respect to x. So it will become x square y plus log of x minus 3 log of y is equal to the constant of integration. So this will be the solution of the given differential equation. So in this way we have discussed the 5 rules to solve a given differential equation which is not exact but can be converted into an exact differential equation. So here we stop this topic. So you have learned how to solve a differential equation which is not exact. Earlier you have learned how to solve a differential equation using variable separable method, reducible to variable separable method, homogeneous form, reducible to homogeneous form, linear differential equation, and Bernoulli's linear differential equation. And now in this lecture you have learned how to solve a differential equation which is not exact but can be converted into an exact differential equation. I think you are benefited with this video. I request you to like, to subscribe the channel, to continue studying various differential equations and their solutions, and also share this to your friends who are in any graduate level course studying mathematics and having differential equation as a topic. Thank you. Thank you once again.